This video will talk about some of the remaining problems that we didn't have the time to discuss during our lecture. So if you look at the first one, it is about arrays, again about loops. Okay. So for arrays and loops, they usually appear together. We usually use for loops. So if you look at this method, what we want to do is we want to write this method called any greater than n. And it takes one parameter num. This method is supposed to return true if any element in the stored array it is greater than num. Otherwise, it will return false. So if you look at those three choices, all three choices use for each loop. For each loop, what it does is to say, let this integer x takes every value of stored array one at a time, and then you're going to manipulate this value in here. So if you look at the first choice, and there's a typo in the slides. It should be num instead of n. Okay, I will change that in the slides. So basically, it compares num with x. If this is true, it's going to return true, or else it's going to return false. So I think for the first choice, logic-wise, there is a problem because it kind of returns false too fast. So for example, if num is 7 and then the array is 1, 1, and 8, the problem is when x takes the first value of stored array, the condition for the if is wrong, then it's going to return false, which is incorrect because in this scenario, it's supposed to return true. So the first choice, A is wrong. How about for C? If you look at C, you compare x with num. If this is true, then you're supposed to return true, right? And then this for loop will complete before you ever try to return false. I think logic-wise, this makes sense because you want to go through the entire list and want to have the chance to return true whenever you find an x that is bigger than num. If you are done with the entire for loop, you never get the chance to return true, then it means everything in the stored array is less than or equal to num. Then you are supposed to return false. So C is the right answer. If you look at B, again, it has a very similar problem with A. So if you don't return true in the first place, I'm going to always return false inside the for loop. That is incorrect. So the correct answer for this problem is C. Now the next one, very similar to what we did before. And in here, we want to know if we use return statement in a different way, what will happen? If you look at it, any greater than n, you have this for each loop, just like before, right? And then you compare x with num. If that's the case, I'll return true. Or else I'll return false, just like before. The only thing extra in here is this line. Okay, so it doesn't matter what do I expect to see. Logic-wise, there's no difference, but in Java, in fact, this is gonna cause an error. So the right answer is E. The error you will see is called, I think, statement unreachable. Unreachable. In other words, this added line will cause an error, and Java think you will never get the chance to execute this print line. It's because you're always going to return true before you get the chance to execute the print line, so it will never get executed. And you may say, well, why does Java care? In fact, this is a very strict way to say if a programmer writes a statement that never gets the chance to be executed, probably there's something wrong with the programmer's algorithm, because logic-wise, you shouldn't write anything in your program that has never get the chance to execute. Okay, so this is kind of a very strict requirement for the compiler. If you have statements that logic-wise can never be executed, Java is going to give you a compile error. Okay, so this is something new. You should know about it. This problem deals with how to pass arrays to a method and how to use loops to manipulate arrays. Okay, so we have this method called match. It takes the integer array and then doesn't return anything. It does some manipulations over here on the stored array, as well as to match this parameter array. And then you have a main. So the question is, in the end, what is the value of my a? So what are stored in this array? In order for you to analyze this problem, again, memory model, right? So let's draw the memory model here together. You have a main, and in here you have a1, which is a box. It is a reference variable. It's going to point to an array in the heap. So the values in this array is here. So this is the heap, okay, part of the heap. And then you have this AP. It points to an array play object. So assuming we are using deep copy in here, so you have the stored array box in here. It's going to point to its own copy of the array, which is exactly the same as 2, 4, 6, 1, and 15. Okay. So the next thing we do is to create my a, right? So my a, again, it is a box that points to another array here that are all ones. It's all one. Then we'll begin to call this method called match from the array play class. So if you look at ap.match, it means let's use the match method from this object in here by passing my a to it. So again, we'll create a stack for match. Okay. So for the match method, it has this parameter called toMatch. Right. It is a box, and in fact, when you pass my a to it, toMatch will also point to the same array. So toMatch will point over here. Okay. And then you have this for loop in the method that will go through the stored array. So it will try to go through this element. Let me use a different color in here. So what the for loop does is to go through this array in here. And the condition we want to do is if the value at the ith position in the stored array is different from the value in the ith position in the toMatch array, we're going to change the toMatch array element to be the same as the store array. In other words, you're trying to compare them position by position. Okay. If they're different, then we'll write the value of the stored array into the toMatch array. So what's going to happen is those values will be changed. The fourth one, they are the same, so they are not changed, and the last one will be changed into 15. Okay. So that's why in the end, the correct answer should be A. Okay. So when you write the memory model, you have to be very careful in here because you have 3 different arrays in this problem. Okay. And anything you do inside the match array will be reflected in the main method because my a and toMatch, they point to the same array over here. Okay. So to summarize how to draw memory models, here is some guidelines. You should already know it, right? So whenever you reach a certain variable declaration, make sure you draw a box for it. And if the variable is primitive, you put values directly inside the box. If the variable points to an object, basically you have to draw an arrow. Okay. Make sure you know that every method should have their own stack. Okay. Basically, if you draw the memory model, basically every method should have their own box. And then you have this heap area that is shared by all the methods. Okay. So the last problem in here before we talk about 2D array is a little bit about strings. Strings that are very similar like char arrays, except you don't express it like a char array. Strings comes with many methods that you can use to go through every character in the string. If you look at this string play class, we can create this hasLetter method. What it does is to see if a certain letter exists inside this word. Okay, so word is the parameter, letter is another parameter. So we want to know if this certain letter exists inside this string word. We'll go through this string one character at a time, and the way you do that is you can write a for loop. The index goes from 0 all the way to basically length minus 1. If you look at it, length, it is not a field. In fact, it is a method that comes from the string class. That's why length has a parenthesis. Okay, so this is different between a string and an array. So keep this in mind. Now, I want to know the ith character in this string. How do I do it? String has this method called char@. Okay, if you give me the index of that position, what it returns is the corresponding character at that position in the string. And if they are the same, great, you found it and return true. Just like before, if you finish the entire for loop and you never get the chance to return, it means this letter really is different from every character in this string. So at that time, you're supposed to return false. Okay. So if you look at this main method, I want to call hasLetter from this s, which is a string play object. So s.hasLetter, the string is sleep. The char that we want to search for is s. So indeed, it exists inside the string. So the value that will be displayed will be d. So found it is displayed, and then you print a line again, it's going to print out true because this method returns true. So this one comes from the hasLetter method. This one comes from the main. Okay. Now let's briefly talk about 2D arrays. 2D arrays, they are two-dimensional arrays that you can visualize it as an array of arrays. Okay, and there are many different ways you can create a 2D array. I would say the easiest way is to do something like, for example, if I want to create a 2D array of size 10 by 10, you can say 2D array x, so 2 square brackets, you can say equals to new int, and then just say 10 rows, 10 columns. Okay, so the first square bracket always indicates the number of rows, and then the second square bracket indicates the number of columns. So 2D array, it is more like a table, more like a matrix than a linear structure. Okay, and if you do something like this, you're going to create this table where it has 10 columns and 10 rows. Okay, so it's always going to be some sort of rectangular shape. But sometimes you want to create 2D arrays that have different number of columns per row. So just like in this example, if we are managing our CSE labs, and there are 6 of them, and the number of machines in each lab is different, So if we want to create this string array that store the name of every computer in each lab, this might be your 2D array. So for the first lab, it has 64 computers. Second one has 56, and go on. How do we do this? How do we create a 2D array that has different number of columns per row? So this kind of array sometimes is called a ragged 2D array. Okay. So the way you kind of process it is you try to visualize your 2D array indeed as an array of arrays. Okay, so each row you can think is a 1D array. Okay, so you have 6 1D arrays, and they together will form another array that will be your 2D arrays. So you can think each row is independent from each other, and you have 6 rows of them. Okay. And we'll kind of talk about how to create this kind of array. And usually, to facilitate this process, you define how many rows you have. So this is the total number of rows. Total number of rows. Basically, in here is equals to the total number of labs. And then you have another integer array. And in here, both of them are final, is because they are kind of constants for us. For this integer array, which is final, it has 6 elements in it, and each of them indicate how many columns you have for their row. So for example, it means for the first row, it has 64 columns, and etc. The question is, what do we fill in A, B, and C such that will make it correct in here? So the first line here, what should we do? If you look at it, lab machines its type is 2D string array. So if you look at 2 square bracket, so we want to create first an array of 6 rows. An array of 6 rows. Okay. So the way you take care of that is first the type of the 6 1D arrays should be string, of type string. So B and D, they are incorrect. Okay. Now, which one is right, A or C? So we want to create 6 1D arrays in here, and in fact the correct syntax is A. Okay. As well, why is A? Basically you are saying I want to create 6 rows. Okay. And we'll just leave the columns blank. So what really this line 3 creates is lab machines this box right now points to an array of 6 elements. Okay. Each of them later on can point to another set of 1D arrays. So the correct answer in here is A. We are not done creating the 2D array yet, but we kind of have a good start. Basically, lab machines points to this template in here that had 6 elements in it. Okay. Now, what is inside B? Maybe we can just use the same thing here. So for B, we want to go through this array and let each of them point to their own array. Okay. So the value in here, I is less than. There are several choices you can have. You can say total labs, which is 6. Roughly speaking, we want to go through this array in here. So it can be total labs in here. Total labs. It can also be the length of this array, which is lab machines dot length. That is okay, right? And also total machines dot length. So basically, we want to have a value of 6 in here, right? So if you look at the choice in the next slide, in fact, more than one of them is right. So long as we fill in the value that is 6 in here, and there are several ways that we can have 6. So this is 6. I think this is also 6. In fact, this is also 6. Okay. So more than one of them is right. Now the last thing, what do we do in here for part C? For part C, what we want to do is we want to create a 1D array in here. So the first element over here will be 1-01, and then 1-02, 1-03, and go on. So if you look at component C, what you will see is should be lab machines I. Basically, we want to index over here the red mark. Okay. So the ith element in the lab machines array, in fact, its type is a string array. So this is another reference equals new string array. So what should be the size of this array? In fact, for the first I, when I is 0, it should be 64. When I is 1, it should be 56. In other words, it is the corresponding value in the total machines. So total machines. Let me erase this side. So total machines I, the corresponding ith element in total machines. So by doing this, basically we are saying let's create individual arrays for each of those elements over here. Okay, and each of those arrays over here that I've just marked, they may be of different length. So they combined together will make this ragged array. Okay, so this is how you create a ragged 2D array in Java. Okay, it can be a pretty hard concept to grasp in the beginning. Okay, just try to visualize a 2D array is nothing but a collection of rows. Okay. So to summarize, what we have reviewed in here is arrays and loops. They are very similar. They usually occur together. Okay, you should know how to draw the memory model. Okay, and there are many different ways to solve the same problem. Make sure you start PSA 1 as early as you can. Okay, and spend most of your time on designing the algorithm. Okay. Don't debug your program by randomly changing stuff. I think if you have your experience in 8A, you know that most of the time it won't work. It will only make things worse. Okay. Thanks for watching this video. Good luck with your PSA.